Alright everyone, me again, working away at the school as normal. So, thought I'd give you another little insight to our day in the life of our school caretaker. So with the school, as everyone, always looking to save a few pounds. One of the things I was recently signed up to do, about 6 months ago I did the training, is to do electrical pack testing. Me and the other site maintenance guy both got put on the course to save the school the expense of calling someone in every year to test all our stuff. As you can imagine, the amount of electrical components there are in a school these days, it adds up to a fair sized bill every year. So we did a day's training and then we bought ourselves a pack tester, which I believe this one costs somewhere in the region of about £270, I think it was. This one is a fairly basic one. Some of them are got a lot more features than this one, but this will meet your requirements to do the basic sort of testing. So that's the device itself, and then along with that comes the various bits and pieces you need. I've definitely got to invest in a little tripod. I must remember to jump on eBay, pick one up, be able to do these films a little bit better than my usual hap-handed way. So in the pack, this here is a little tester that you can use to try and find a good earthing point on a device. If you're having the items fail in the pack test on saying it's got a bad earth, then you really need to use this to make sure that the points you're testing it on are a suitable earthing point, or you might be failing an item that's actually not got anything wrong with it. This probe you would attach to the machine, and as you're doing the test, this is what you would hold against a point on the device you're testing for it to establish that it has got a good earthing point. You can either use this if it's something like the inside of a kettle where you can clip that onto the element and then let go of it. Other things you may be a bit tight to get to, that piece will pull off, then you're just left with a point then that you can stab about and hold in place. And this lead you would use for testing things like that extension lead there. This part plugs into the top of the machine, and if you were testing an extension lead, I'll do one actually to show you. Basically the extension lead would be plugged into there, and then you would then put that into all the various sockets on the extension lead and test each one individually to make sure that they're all working as they should be. I'll say this little tester, let's try and see again, I don't have a view on the front of this camera, so I'm always wondering if I've got it at the right angle. But say if you were having trouble getting something to pass the test, you might be using a point, although it might be metal, it might not actually be connected up to anything inside for it to establish the earth. So the way this would work, got a little crocodile clip, put that on the earth pin on your plug, and then find a metal contact on the thing, press a little button, and if it's got an earth, it will light up and buzz. Now sometimes you do have to hunt about, because some of these might be a good earthing point, and even though you're getting a buzz, sometimes it might not be quite good enough for it to pass. So sometimes you do have to have a little bit of a mess about and hunt about if something keeps failing, just to make sure it is actually faulty and it's not just a case of you've got a rubbish earth point. So I'll show you how it would work testing this device. So I'm back. Bloody battery went flat again. I really have got to improve on my filming technique. It's a bit piss poor. Right, so getting a lot of glare off the light above us. So I say the device that you're testing, you plug in to the tester. Then we have the earth probe. Now you only need to use this obviously on items that are earthed. That plugs in there. Now I'll hold this against this lightly so it'll probably fail, so you see what will happen. So basically with this earth probe, say once you've established something you think is a good earth, you just hold that against it and then press the test button. Now, as you can see, that's failed that item. Now that's basically saying bad earth continuity, so that would obviously fail that item because it would be unsafe. Now I'll do it again and press against it a bit firmer this time. Hopefully this time round it will not fail it. Right, now that's it passed basically, and it's a straightforward. It either tells you it's passed or it's failed, and it will say whether it was the earth continuity or an installation is the reason for it failing. Sometimes that one does where it comes up saying check connection. I mean, this is a big speaker so there isn't actually an on off button, but sometimes if it's something that has to be switched on like a kettle or anything really, if it's not switched on, then it senses basically that it's not going through the system and checking it properly, and it will tell you to check that the item's switched on. Something like this where it's a speaker that doesn't actually have an on-off button, then basically all you do is press the test button once more to tell it to continue testing as it is, and then that will complete the test. So that's one item done. I'll disconnect that socket and I'll show you how that goes. Now say some things are earthed and some things aren't. So basically you've got items that are classed as a class 1 item, which is something that has an earth wire in it, and something that's classed as a class 2 item, which is something that does not have an earth wire. They are basically double insulated inside. Just have a little look on one of these little power packs for these little piano jobs here. Depending where the stickers have been put on them. I don't know if you'll see this, where are we? You see there that little square box basically is a picture of a box and a box within a box basically. If you see that on any item, that is letting you know that that item does not have an earth wire on it. And the way they work, the electrical connection inside that item is connected to wherever it's connected, and then it's sealed in a layer of plastic, and then there's a secondary layer of plastic put over that. So if that wire was ever to break loose for whatever reason, it would not fall off and hit something that would then render the outer casing of that item live and potentially giving someone a shock, because plastic does not conduct electric, so therefore that item's safe. Whereas an item that has an earth wire on it, if the power wire inside that item was to come off and hit against the body, then the body of that item might well become live. At that point the current would shoot down the earth wire back to the electrical fuse board, and that's what would cause your fuse board to trip basically. So that's the basis of how this all works. Alright, I shall tune out for a second. I'm back once again. Every time I try filming something at this place I get a bloody radio call to go and do something. But I am supposed to be working, I suppose. So this pat testing lark, although people make a lot out of it, the actual testing itself is very, very simple. And we've done a 4 days course, and to be honest, a lot of the stuff, although some of it was interesting, some of the details I gave you now to work certain things out was interesting. I think a great deal of what I was given on that course, I felt like I was sitting there taking the first steps to trying to become an electrician, the amount of data I was getting. But I suppose someone's got to make enough contents to justify charging some a 4 days training, but they've definitely got a lot of information that I don't see that are needed to enable me to do this job. So we'll move on to testing a 4-point sort of extension lead. So again, on this particular device, hold the 2 buttons down to switch it on. Now with this, again, plug the extension lead into the machine, and then this yellow lead you'll put into each individual one. You don't just test one and it passes and that's it, because there could be a fault on one particular socket point. So you'll plug that in like so, and on this particular machine it has a button that is specifically for testing leads. So you will press that, and then the machine will start its scanning. And with this particular machine it's just a straightforward, tells you pass or fail. It would identify sort of one here which it had done, so that does the earth continuity, the insulation and the cord. So I don't know whether that, I think that's probably the cord is maybe just actually checking it's wired in the correct manner, I believe is what that is. So again, you do that, take it out, do all the individual ones, and then if passed, we then have to, this won't show up too well on here, we have to put a label on the machine stating the date you tested it, the initials of the person who tested it, and you will give it an ID number, because we have to list every individual item. And we do have to put on the computer then, we'll log the location the item was, what the item was, whether it's a class 1, a class 2, and obviously whether it passed or failed. And then if this is the first thing I was doing in an entire school, this would be item number 1, and so on and so on. Currently I think I'm up around about 390 is what I'm up to so far, and getting to the end, not got too many more things to test I don't think, and that's us done for the year. Now what we dreaded when we first got told we were going to do this is that we thought we were also going to be getting all the computer items to do as well. That would have been a nightmare, quite frankly. I don't think we would have been able to do it because there's so many computers in the place. And if you test any item like this particular one, this big speaker, where the power cable actually unplugs, the way you have to do it is test the lead on its own first to check the lead's okay, then plug it into the machine and test the machine. The idea of that being, if you just tested this with just the machine itself and it failed, you potentially could be throwing an expensive piece of equipment away, when actually the device itself is okay, and maybe there was just a fault with this power lead, which is now an item you can probably buy for, I don't know, £3 or £4 probably. And then because it's detachable, you would put that sticker on the plug as I've just shown you and label it, and then you would also put another sticker on the device itself with the same ID number on it, and then basically you're marrying them 2 items up. You're saying this item was tested and this is the lead at the time that was on this device, just in case at some point the two things get separated and someone pulls this off one day because someone else isn't working and pulls that one off and sticks it on something else. So that's the idea of that basically. And the other part of the test is you do a visual inspection of the cable. If there was any big nicks out of this or cracked and you could actually see in to the cables inside, then that would be a fail. If there was any damage to the plug itself, if this casing had a big crack in it, or there was an actual chunk of the plug broken off or something, or any bends to these pins, then again that item would be failed. And the other thing you do is check it's got the right ampage fuse for the item. So it's all fairly straightforward really. So this is the first year that this has been down to us to do this in the school, and it hasn't been as bad as we were expecting, and that's mainly down to the fact that in the end they decided they would get our IT technicians to do the testing of computers. They bought them another PAT tester which is a bit more advanced than the one that we've got, so on items that could be sensitive like laptops and things, I forget what the actual voltage is now. It's a very short pulse, but it's something stupid like really high voltage. I don't quite get how this does it, because it's actually battery operated, but it actually puts quite a high quick jolt of power through the thing, so it's something like a laptop. There might be a possibility of damaging it. So with the PAT tester they've got, you can actually regulate how much power you used on the test. So if it's something they're a little bit concerned about, they can reduce that testing power down to about half of what this one uses, just to play safe and they don't cause any damage to it. And on their one, it actually gives you readings like what the resistance test was on the earth cables, or all the cables, so they can actually jot it down if they want to, and I think they do on their record. So you can actually see over the years, you can compare them numbers and see are them cables slowly deteriorating, like their resistance levels creeps up as the years go on. So depends how accurate you want to be with it. And with the really expensive devices, you can actually store all the information in it. Then at the end, you can go and plug it into a computer and it will transfer it all on there, rather than like we do, having to sit there and manually input it all. And you can also have one where you plug into it and it will type out the labels that you put on the plug, as opposed to writing them out again like we do. But it's obviously then you're talking machines that are about £1,000 then to buy a kit like that, which you would obviously only be doing if you were doing this for a profession. So just a little insight into another part of our job as a school caretaker these days. Yeah, catch you later. Everybody, right, just got back home about half hour or so ago. So I've done my little PAT testing thing, been a bit manic, again trying to do it in between getting radio calls every 10 minutes, always seems to be the way. If I try doing a little bit of filming there, something's happening. So just to finish off what I was saying, so we've done the day's PAT testing course, which I think they drag on more than they need to, and certainly got given way too much sort of technical data as far as electrics and things go. Really was sat there halfway through this thing feeling like I was taking the first steps to becoming an electrician, the amount of sort of technical stuff that were being given. But I think that's just a case of them filling the course out basically to justify how long sort of that's how much they're charging you basically. They could cut you down to half a day's training and that would be fine. But one little thing I'll show you out of all the technical stuff they gave me, which I did think, oh well, that's handy. I think like most people, you just pick up a 13 amp fuse and throw it in pretty well everything, which you really only the high powered items need it. Things like kettles and heaters and drills and that sort of thing. So if you actually want to work out what size fuse something needs, if you look on the back of most items, it should tell you on there how many watts of power that particular item uses. So let's just say, for instance, it's somewhat quite small and it's say 750 watts. So you'll mark down wherever it is, and then you divide it by 230. Don't have this shown up on the camera too well, and you'll see there it's 3 point, then a ton of numbers. All you want is the first number basically, so that's basically saying a 3 amp fuse is what you would need for that. Now the 230, that's what the AC power is coming into your house. Now I was always under the impression it was 240, as did quite a few other people on the course when the guy just threw a little question out there as a little catching us out. Now it was 240 for many years, but apparently quite a few years back, doing our little bit for the trying to reduce global warming, it was all turned down a little bit, and the power coming into your house actually these days is 230 volts. So whatever you're doing, so a small item like that was saying just over 3 amps, so that would obviously be a 5 amp fuse you'd put in that. Let's say something that's 2000, that would come out at an 8 amp fuse. So obviously with that one you go as close you can, so for that obviously it would be a 10 amp fuse you would stick in there. And I just looked at my kettle, which is a high powered item that you'd expect to be a big fuse, and as expected that one is 13 amps. So that's a good way of quickly figuring out what you should be putting into items. The main purpose of that isn't protecting you, it's protecting the device. If you've got something that's maybe only meant to have a 3 or a 5 amp fuse in it and you put 13 amp fuse in it, there's a little bit of a power surge, which is something you get in your houses. You just get, say, a little bit of a power surge through the system. Now that goes into that item and it's got a 13 amp fuse in it, it's obviously going to take quite a big power surge without blowing that fuse, and if that item's only meant to have a small current through it, then potentially the item itself could be damaged. So it's worth thinking about, especially if it is sort of maybe little things that are quite expensive. Maybe it could be an expensive stereo system in your house or something that's probably only meant to have no more than a 5 amp fuse in it. You put a 13 in there and then something happens, you could fry that stereo system. So it's worth thinking about. Right, I shall load this up and hopefully it's not too rubbish. Must invest in a tripod. Really is tricky trying to film things when you're holding a camera and trying to do everything else with one hand. Alright, enough rabbiting, I'll get this loaded up. Bye for now.